Next, let's talk about map pre-processing and map verification, verification and editing. All right, so I'm just going to kind of quickly go through some of the things that you may want to have, you may need to do to pre-process your data to get into a format that is most suitable for going into the next stages of actually using the data. So before you actually use it, you may need to transform it in one way or the other. Why you might need to do that is going to vary, but I just want to show what some of the options are. One, you may need to reproject your data. And that's what we've been talking about with the different coordinate systems. You may need to change projection, and that changes the coordinate system. You might need to change the units and also what data it references. So we talked about troubleshooting in the last video, and what you could do to fix that is you could either redefine the projection or you can change the projection. To actually change the projection, there's a tool called project, and you give the input feature class and the output feature class, the input coordinate system, and any kind of, and this would be whatever, it kind of defaults for you transformations between different datums. Another thing you may need to do is you may need to georeference data. So if you have, say, a scanned map and it does not automatically align to your GIS, it's just a simple image, you may need to use georeferencing tools to choose points on the image and align them to your GIS. You might need to do this with scanned maps, aerial photography, and you line them to GIS features, and then that can be saved. And what it does is it saves what's called a world file. And a world file is a text file that can be saved with your image that gives the transformations that allow it to align to your GIS. It defines what the pixel resolution is of the, once you've aligned it, it can calculate what the new pixel resolution would be, how much it should be rotated, and the X coordinates and Y coordinates of whatever corner that it's in. And this is just information that allows you to then pull the image back up. And the next time you won't have to georeference it because it'll have a reference file saved from when you previously georeferenced the image. For raster data, again, that's the data which is a grid of cells. You might need to resample the data. You might need to change the resolution. And what we're talking about primarily is really going from finer scale to coarser scale and changing the size of the pixels. You can't really go the other direction. It doesn't really help that much. But let's say that you need to, you're doing your analysis at, with 100 meter pixels, like here on the right, you get some new data that's at 20 meter pixels. You can resample that down to 100 meters so that it is at the same scale as the other data that you're using. You also may want to reclassify your data, or that changes the numerical data in the raster. And again, this can be used to generalize categories. So here we have 4 different categories on this raster, but we want to simplify them. There are tools that we can use to simplify them into 2 separate categories, where one kind of gets absorbed into, like the blues get absorbed into the greens, and these grays get absorbed into this kind of magenta category. So now we've gone from 4 categories to 2 to generalize it, because maybe that's how we need to present our data for analysis. Other things that you might need to do, you might need to edge match data. If you have data that was created on different map sheets, maybe created independently on separate map sheets, maybe the case that the edges don't quite match up and you need to kind of snap them together. With scanned images or raster data, sometimes you might need to use what's called conflation or rubber sheeting, which allows you to kind of pick out real world features that exist on the map to kind of twist it, to distort the shape to better fit your GIS data. And another thing kind of the opposite of edge matching, you might want to break your data up. You might want to break, if it's for some analysis, it may be helpful to break up your data into different map tiles. And so that way you can process each one independently if perhaps it's too much data to use as one big file. This is not often used, but there might be occasion where you might have vector data that you want to convert to raster or vice versa. And there are some tools to do that. This is never a perfect process because, you know, you're better off, if you need raster data, you're better off starting with raster data, and vice versa. If you need vector data, you're better off starting with vector data. But that being said, if you do have data that you need to convert, it is possible to do so. Coordinate thinning or map generalization is another option. If you have very densely spaced features, or so lines are a series of points. Just to back up. So lines are a series of connected points, and those points are called nodes or vertices. And sometimes data can be very densely digitized with a lot of vertices, and perhaps you want to simplify that into a more generalized feature. What you can do is thin out some of the nodes or vertices and simplify the line and make a smoother shape out of it. So this tends to smooth it out and make it a bit more smoother. So now you have this very dense coastline to a much more generalized coastline. And lastly, topological functions. So topology is a spatial relationship among features. You know, how do they connect to each other? Do they overlap each other? Are they, you know, are they connected properly? And this relates to checking for errors as well. So this helps to clean up problems with your data. Problems can include slivers, which is where you have two lines that are very close together, and where it should be a single line that splits two features. It's not quite right, and you end up with a little sliver of a polygon that shouldn't be there. You can have an overshoot where one line, you know, went too far over the other one instead of snapping to it. Or undershoots, which is the opposite problem, where it didn't go far enough, it didn't quite snap to that line, leaving a gap there and an over, you know, a line that's crossed over here. And sometimes you can have redundant features. You might have two lines that are separating a polygon rather than a single line. And those are considered topology errors. And there are some automatic ways that you can clean that up. And then there are some manual ways. You might have to go in and find those. There are ways that the system can flag those errors for you, and you then go one by one and clean those up. Okay, and then moving on to map verification and editing. Map verification is about identifying and editing errors in the map. And there's a few ways you can do this. One is just visual identification, viewing the map, looking for errors. We talked about topology a moment ago. There are ways that the GIS system can check for topology errors, and flag those for you. There are processes where it can clean up some things automatically, and then there are some where you need to kind of view and resolve some errors yourself. And then lastly, you can compare your map with other documents, other source materials, to see how well what you have in the GIS aligns with, say, a paper map that is that goes with whatever it is that you're working with. Now, if you do have problems, you may need to edit your data. And oftentimes this falls under the category of what we call digitizing. And digitizing usually refers to creating spatial data, but digitizing can also encompass editing spatial data as well. So you can, in addition to add features, you can delete features. You can split or merge features. That's often part of the process for creating features. You may create a large feature and then split it into smaller ones. And conversely, you may want to take smaller features and combine them or merge them into a larger feature. You might need to move features, like say if a point is in the wrong location, you could move it, or you might need to change the shape of features in some cases. And lastly, another thing we can do is what's called geometric conversion, or change the type of geometry from one to the other between points, lines, and polygons. So the three basic types of geometric features in a GIS are points, lines, or what we call polylines or groups of lines, and polygons. So you can take a series of points and connect them together as a line. You can take a series of points and enclose them as a polygon. You can take a set of lines that are closed and convert them to a polygon, and vice versa, from a polygon to a set of lines. You can convert lines. You can calculate the centroid, the center of the line, as a point. And likewise, like here in this image, what this is showing is for each of these polygons or states, the center is converted, is identified. So you're really converting from a polygon to a point.